So 11.12, amino acids in acidic or basic conditions. So first they said, if acid is added, the COO minus part of the vital ions accepts an H plus ions. So you can see here, originally they are neutral, but if you add acid, that means you add H plus. So then we go to the left. If you add H plus, right? So basically the negatively charged COO minus will take the H plus and form COOH. And losing the negative charge, and hence this vital ion just now form a positively charged ions. So you add H plus, it form positive ions. If alkaline is added means you add hydroxide, you add OH minus. The NH3 plus part of the vital ion donate NH plus ions to the OH minus. So that means if you add OH minus, then one of the H plus will come out and neutralize with the OH minus to form water, and because of that, here no more positive charge, and making the whole ions take negative charge because of the presence of this negative ion is formed. So when you add OH minus, then they form negative ions. So reforming NH2, as you can see here, and H2O. H2O because the H plus from here react with the OH minus to form H2O, leaving a negative charge. So this is the negative charge. Now 11.13, peptide bonds. Peptide bonds is where two amino acids join up, then the bond in between, which is the amide. You know this is the amide group. This amide group here is called peptide bond. So should we call it amide? Of course can also. You can call it amide. You can also call it peptide bond in specific when they involve two amino acids. So the amide link is this one, the amide link, formed by nucleophilic attack of NH2 group of one amino acid on COOH group of another. So this is where it happens. This is one amino acid, the NH2, which is basic, react with the COOH of another amino acid, which is acidic. So they form H2O. Okay, take the H here and take the OH here, form H2O, and then the remaining join up, the C and the N join up in this way, and that is peptide bond. Okay, now let's move on this side. Reactions can continue to occur as products still have NH2 and COOH group present. So what are they trying to say? You imagine, you look at the picture. So once they form the dipeptide bond here, this left hand side is another amino group. Okay, the basic amino group that can further react with the COOH of another amino acid. Then they can form another peptide bond here. Likewise, here is C double bond O and OH. They can react with NH2 of another amino acid and form another peptide bond. So you should be able to imagine this is where two amino acids join up. Then this side is possible to put one more amino acid, and this side is possible to put another amino acid. And the process can keep extending, This side also can keep extending, so until it becomes a long chain, and that long chain is polypeptide. Polypeptide is just a protein, basically. Okay, now you can see here. That's why amino acid join up, then they form protein. So dipeptide is 2 amino acid join up. Tripeptide is 3 amino acids join up. Polypeptide is more than that. Many amino acids join up. So we call it polypeptides, or you can call it proteins. So proteins are polymers. Okay, so it is polymers because they are joining up and it's a very long chain. So we call it polymers of amino acids. Many polypeptide chains help together by intermolecular forces. Yeah, so imagine they can link together, So one polypeptide like this, and another polypeptide like that. Yeah, they can form different kind of bond, like induced dipole and temporary dipole, or they can form hydrogen bonds also. Okay, they can just link together, and then they can form different kind of structures. Okay, so like alpha and beta structures. So that is for biology, where we don't need to care that much. Now here, let's move on. Once they form polymer, so you can just hydrolyze the amide. Hydrolyze the amide is something that we discussed just now, where you can use acidic hydrolysis. You can also use alkaline hydrolysis to break down the bond here, where they will change it back to COOH and NH2. So it is possible to do it. So we call that hydrolysis, and it involves breaking of peptide link by reactions with water catalyzed by an acid or alkaline catalyst, giving back the amino acids. Temperature is nearly 90 degrees Celsius. So that is the breaking down. It even happened in our stomach also. Okay? So at the temperature of 37 degrees Celsius. So hydrolysis happened in our intestine. So where the proteins break down to amino acids. So it happens also. So because of enzyme. Enzyme. So we don't need the high temperature because our stomach produce enzyme like catalyst. Okay. So here, electrophoresis. Electrophoresis. Okay. So electrophoresis is a technique to separate the different types of amino acids. So as you can see here, electrophoresis is used to separate, identify, and purify amino acids obtained when protein hydrolyze. Protein hydrolyze means you break down the protein's polymer into amino acids. So different amino acids, you have different charges, you have different mass, and because of that, it can be separated because of the charges. For example, you put your sample somewhere in the middle, okay, and then left hand side is positive charge, right hand side is negatively charged. So the sample is hence separated. The negatively charged amino acid will move to the left, to the positive terminal. The positively charged amino acid will move to the right, to the negatively charged terminal. If they are neutral, they will remain in the middle. Okay, so, and of course, if they are light, they will travel faster. If they are heavy, they will travel slowly. And because of that, we can separate them because of this kind of concept. So likewise, for the negatively charged amino acid that go to the left, if they are light, they can move quickly. If they are slow, then they will move slowly. So that's why here, technique based on separating ions placed in an electric field. When sample placed between two electrodes, so imagine we put our sample here, put in the middle. Okay, so the positive charged ion move towards the negatively charged electrode. So as in here, the positive charged amino acid will move here. The positively charged ion will move to the negative. That means positively charged amino acid will move to the right. Negatively charged ion move towards the positive charged electron. That means negatively charged amino acid will move to the left. Sample placed on absorbent filter paper or gel. That means for this case it's a paper. The sample you put in the middle. Buffer solution carries ions along, back or forth. So you can see we put buffer solution here. Okay, so buffer solution is basically a solution that maintain the pH. So maintain the pH. So because of that, they won't change in pH. So when pH change, then the charge also change. So we don't want that to happen.